What's up, guys? Let's move on. This is our sixth class where I'm going to show you how to put the information into a software analysis. I'm going to use here the BridgeLink, an amazing software that can help you a lot when you plan to design and to take information from loads and shear stresses and bending moments on your bridge. All right, we are going to set the software step by step, so pay attention, and you're going to take also a PDF paper where you can use in order to understand if you are new on the BridgeLink software or and the design of bridges, stressed bridges. So welcome to this class. So I'm going to begin here. This is the first view of the BridgeLink software. I'm going to set here a new bridge. All right, since I know what kind of girder I'm going to use, and the closest section that we got here is the Texas 70. This is a BT 70 girder, so I'm going to use this model, all right, in order to set our bridge. I hit OK here. So you got see this window here. You got the take the name of your bridge. So this is the bridge 120 feet example. All right, this is the bridge ID. You put it, I'm putting here the lesson number. All right, this is my name, and this is the institution here in Brazil where I teach about engineering and structural engineering. All right, so the software shows me the first screen here where I can see the girders, the deck, the barriers, the spans here. It's not, we're going to set correctly this span here. You can use a menu here where you can set any variables in order to design your bridge. All right, but you can simply double click on your element, so it's going to show you the properties of these elements. For instance, let me set the barriers here. This is not the barrier that I want to use on my project, so I'm going to set here a CSB barrier to both sides. All right, so I click right and right. So when I hit OK, see, I've got the on both sides our barriers. Let me take out my cam here. So this is it. We got the bridge barriers set. Okay, the deck is not good, so I double click here and it shows me a window where I can change many variables here. I see the I-beam, that's correct. The Texas 70, that's correct. This girder spacings, let's use the number that we are using in our classes, 12 feet. Spaces between girders. Layout, let's change here. This is just one single span of 120 feet, so I change here. Girders, they are good. The abutments, connections, you can set here for 0 because the software wants to put the bearings a little distant from the edge of your girder. So in order to take the exactly points for this example, I'm going to set it as 0 here also. I don't want to analyze the bearings away from the edge of the girder. I want them to be aligned. All right, so this is why I'm taking 0 on this distance here, the bearings. All right, okay, this is okay for me. I'm going to hit 0 here. All right, because I just want one span of 120 feet. So the railing system, all right, I removed it correctly, the second span here. So the railing system, all right, deck geometry, I want to take this as 42 feet. So I got here number 22, all right. When I hit OK, this is correct set. And we see that we got a wrong set of girders. We just need 4. There are 6 in our project, so I'm going to hit again and say here the spaces is right. The number of girders here 6. No, wait, we just need 4 of them. So I hit OK. This is it. We are going to set our bridge correctly. So the BT70 here, the deck geometry, let's see, overhang, edge depth, let's make it just 8 inches. All right, 8. This is it. We got a haunch geometry of 2 inches. Our FC prime is correct. We are not going to use on this class the design of the strength of our bridge. We just want to analyze the loads of the HL93 and the load lane. All right, this is the main objective of this 6th class, right? Sacrificial depth. Okay, this is the wetting surface. You want to put it here, 2 inches. All right, deck reinforcement, we don't have to set anything right now. The environmental, let's use 70% of humidity. This is it. All right, our haunch, I see the haunch not good here. Haunch just had a 1 inch thickness. All right, so this is right. So in the end of the day, what you have to do is just to hit this little engineer face, and you get the first window in order to design this bridge. So you hit design multiple girders. I just wanted them to be all design, so I hit select all. It's going to design the 4 girders of our bridge. I hit OK, and you can choose here if you want to design for flex shear or if you want to design for shear. I'm keeping I hit here, so the software is going to design the bridge for both stresses. All right, so I hit run design, and then you got the load truck passing over your bridge. This is amazing. It's amazing software. Thanks for Washington Department of Transportation, Washington DOT. This is amazing because it helps you, a student or a professor involved into the design of bridge and classes on bridges and bridge design, especially pre-stressed bridges like on this course. It's going to help you a lot. All right, so let's wait a little because it is designing the whole structure. So we got the results here. As you can see, this is not good for flexure design. Failed. All right, no problem. Let's accept. Just hit here, accept the design. This is a little summary of what the software did for your bridge. So let's see the reports here. You can choose any of these reports. I'm going to hit bridge analysis report. I'm showing a interior girder, so I choose from A to D. I'm choosing the girder B. Hit OK. It runs a little analysis again. So these are the results. I love this table here because on this table I can see the point analyzed. All right, as you can see here, I got the points from the left here, the left support, the tenth of the length of a 120 overall length for our girders. I got the point 12 feet, 24 feet, 36, 48, 60. That's half of our bridge. As you can see here, half of their overall length. LS is the overall length of our bridge, of our girders. So these are the results for moment, and here you got the shear stresses. All right, so it's amazing because the software shows you here where are the axles of your load truck. For example, the rear axle is at 12 feet, so plus 14 feet we got the 26 feet. This is the middle axle, and plus 14 feet we got the front axle of the truck with the load, standard load of 8 kips at 40 feet from the left support of our bridge. So this is the result that we got. All right, I'm going to show you how to calculate it manually also. So let me show you here. Here in MathCAD, I'm going to set the equations in order to find the proper moments results for the load truck and also for the load lane, but I had to find the equation of the load lane point to point in order to get the exact moment, bending moment and shear stresses. So I'm going to use my emulator for the 50G calculator here. If you want to know how to set it, how to put that information, please leave a comment down below. I'm going to help you on how to do this analysis, this bridge analysis, and this amazing software. If you have the calculator physically, it's the same process. All right, so let's begin here. I had to set my mode from algebraic to RPN. This is the mode that you can run instructions into the calculator. So I'm going to access my VGG software. I'm just setting the diagram for shear and moment using the down as a positive moment and shear. I hit OK. Let's enter a new one bridge. The length 120. Hit OK. Hit enter. Return. The inertia is constant. So I got one, just one. The left support and the right support. So this is the first sketch of our bridge. All right, let's input our load lane. So distributed left load dot 64. Hit enter. It starts from 0. Hit enter. OK. The other side will be the same load, kips per feet, and the distance, the final distance, 120 feet, because I wanted this load lane over all the length of our bridge. All right, so I hit OK, finish, save data. No, I don't want to save it. So here I can have the result for shear, moment, rotation, displacement. I want the moments first. Equation, it shows me if I had a change on the loads. I don't have, so it goes from 0 to 120. I hit OK. This is the equation that we are going to use to find the load lane moment. I hit here to simplify it. So this, I'm going to copy this equation into here, the MathCAD software. So let me write it. 32 times x to the second minus, minus 38.4 times x. All right, so I hit return here. So this is it. Let's see what happens. These are the results for bending moments for the, let me copy this into here, change the color because I want to be the same. All right, this is the result that I've got in the end of the day. Let me hide for the little my calculator here. So we got the moment caused by the load truck and the load lane. In the end of the day, I'm going to sum it in order to take the results for this point of our bridge. I'm going to change here for the first point. Let's see, we got here these two results, but I got to multiply it by the impact factor. Don't forget it. So what I'm going to do here is just to multiply it by 1.33. So these are the results in the end. So my final moment, final at this point would be the sum of the moment caused by the load truck plus the moment caused by the load lane equals, and just change it here in order to get the right result here. All right, so this is not a good. These are the results for the point 12 feet from the left support. All right, see how it fits. All right, 1359.55, so it fits perfectly. All right, I can change it. For example, if I change it for 24 feet, 2397. 2397. So I'm showing you how the software process the idea of loads. All right, so I had to do in the end of the day just a sum of both moments caused by the Agile 93 truck and the load lane, but I multiplied the moment for the load truck by the number 1.33 because I had to consider the impact factor here. I ended with these results here. I can change it also again one more time. This is the limit for this equation. All right, so I can see for 36 feet. Let's see, 31, 11, 12. 31, 12. All right, so it's proved that these equations work properly, so you can use them. I'm going to show you here for another point of view. This is the equation for the shear. let's see what happens. Let's see in the calculator here, the cancel here, because now I want to show the shear. I call the equation. All right, this is the equation for finding the shear stresses. So I'm going to put it on the MathCAD software here. Put it down here. This is the shear for. So these are the results that I got. They are very, very close. See here, I'm summing the shear for the load lane and the load truck. I've got 74.9 kips of shear, and we're analyzing at the 0.36 feet, 78. Very close. Let's change it a little for the 24. The second point, what do we got? 92, and here in the table of the bridge link, 93. Very, very close. So it proves that we are in the right direction. All right, guys, you can use it. So if you have any doubt here, please leave a comment. I want to show you guys one other way to prove that we are going the right analysis here. I'm using the F2 software here, so I can do the same analysis. All right, so I put my bridge here, 120 feet. All right, and I put also the load truck here, 32 8 kips, spaced between 15 feet, and these are the points: 12, 34, 30, 24, 36, 48, 60. I'm using a impact factor of 33%. This is I've got no load lane here because I'm going to do it separately, because I don't have to use the impact factor for the load lane. All right, I run the analysis. These are the results that I've got. All right, the same 944 that we saw in our analysis for the MathCAD software. All right, here. And for the load lane, let's go back to F2 software. I'm changing here from HL to the load lane. See, I'm not using the impact factor for the load lane. Let me leave it clear for you. 414 kips per feet. Let's see here. So in the end of the day, when you sum them all, you got 12 feet. All right, you got the same result using the MathCAD software, or you can use a calculator using the equations here. You can see it in the F2 software, the same results, or you can use the BridgeLink software where you can see the results. It's a complete software for you guys that are learning how to design a bridge. All right, so this is the end of our class. I hope you guys enjoy. If you have any doubt, please leave a comment down below. This is my pleasure helping you. See you in the next time.